The desire to contact intelligent life on other planets is much older than the UFO craze and the search for extraterrestrial intelligence movement. Several 19th century scientists contemplated how we might communicate with possible Martians and Venusians. In fact, as history shows, ideas for interplanetary communication have largely been driven by whatever the current technology allowed, be it lamps, radios, or lasers. Now, in a new era of technology with powerful telescopes and spacecrafts, scientists are going to give the alien hunt another try, and they believe that it will definitely be worth it. Welcome to Mystery Hub, where we unravel the deepest and darkest mysteries of the world for you. In today's video, we are going to talk about how and why NASA is going to try to contact aliens, and whether it will be successful or not. So if you want to know more about it, then stay with us until the end of the video. Since time immemorial, humans have sought to establish contact with extraterrestrial life forms. Hollywood movies like Extra-Terrestrial and Arrival, etc. are proof of this curiosity, and all of them paint different scenarios of what might happen if the contact is in fact established. Now, a NASA-led team of international scientists are once again planning to satiate this curiosity. In order to achieve this, they have developed a binary-coded message that they propose beaming out across the galaxy in the hopes of finally establishing contact with aliens. Named the Beacon in the Galaxy, the cipher consists of principles of communication, concepts of math and physics, and even DNA constituents. Interestingly, the scientists have also encoded the coordinates for aliens to accurately pinpoint the position of Earth in the universe. But the question is, how would the message reach aliens? This project is being led by Jonathan Zhang from NASA's Jet Propulsion Laboratory in California. The team aims to broadcast the binary message into the Milky Way's galactic center using the California-based SETI Institute's Allen Telescope Array and China's 500-meter Aperture Spherical Radio Telescope. To ensure that the message reaches aliens, if any, the astrophysicists will beam it to a dense cluster of stars which lie near the center of the Milky Way. This location has been chosen because scientists believe it to be the most promising location for life. According to sources, the scientists wrote in a preliminary paper, "Humanity has, we contend, a compelling story to share and the desire to know of others, and now has the means to do so. However, there are some scientists who warn against sending Earth's location to aliens. While the idea of approaching aliens does sound thrilling, an expert from the Oxford University's Future of Humanity Institute, or FHI, has warned against broadcasting the aforementioned information. In an interview, Anders Sandberg said that handing out details such as Earth's location and DNA data might be risky, irrespective of how small the probability of alien life is. We have very little evidence about whether this is high or low, and there is no scientific consensus. Given the downside could be much bigger than the upside, this doesn't sound to me like a good situation in which to take active steps toward contact," Sandberg said. It is worth noting, however, that this is not the first time scientists are beaming an encoded message for aliens to find it. The previous instance dates back to 1974, when astronomers sent a message similar to the beacon in the galaxy using the Arecibo Observatory, located in Puerto Rico. Back then, the message was directed toward a star cluster in our galaxy, which is about 25,000 light-years away, but there has not been any response from the other side to date. Another concern about sending the message is that the technology needed to send the message is not yet ready, and if and when the note is transmitted, it would take thousands of years for it to reach its destination. In other words, no one expects a return message from ET anytime soon. But researchers behind the alien memo hope their idea will open up a dialogue about how to contact aliens and what to say, and how to immortalize humanity as a species. We want to send a message in a bottle in the cosmic ocean to say, hey, we are here. Jonathan Zhang, an astrophysicist at NASA's Jet Propulsion Laboratory, or JPL, in California, stated. Even if we are not here, some years later, he added. The message designed by Zhang and his team builds on previous missives that humanity has sent to space. In fact, researchers timed the creation of the new message for the 50th anniversary of the Arecibo message. That 1974 message used binary code and conveyed information about humanity's base 10 counting system, common important elements, and a map of the solar system. The new message also encodes information in binary and describes basic math, physics, and biology that aliens would need in order to understand humans, including descriptions of DNA, amino acids, and glucose. It would contain a map of the Milky Way, the solar system, and Earth itself, including information about the makeup of the planet and its atmosphere. However, the message is more advanced than its predecessors in several key ways. First, its map of Earth's location in the Milky Way is more precise than the one in the Arecibo message. In that message, scientists tried using location of rotating stars called pulsars as signposts to pinpoint Earth. But pulsars' position aren't consistent enough over long periods of time, and these stars aren't easily differentiated from one another in the vastness of the galaxy. Zhang and his team instead used globular star clusters in the Milky Way as landmarks on their proposed map. These spherical huddles of stars are bright and easily visible, and they have enough distinguishing features that they can act as a useful signpost. The researchers also included a first-of-its-kind timestamp so that any alien intercepting the message would know when it was sent. But how do you convey time in an unknown alien civilization that might have a very different way of measuring than Earthlings do? The answer, according to a co-designer, Quinten Jin, of the Hans University of Applied Sciences in the Netherlands, was in the hydrogen atom. The neutral hydrogen found in interstellar gases can enter a high-energy state after collisions with other atoms or electrons. After about 10 million years, one of these high-energy hydrogens undergoes a transition back to a lower-energy state, an event called a spin-flip transition. This spin-flip transition provides a convenient universal unit of time for communicating how long after the Big Bang the message was sent. I think that is pretty important, for if you see it like a time capsule, when someone receives it, they know when it was sent, Jin stated. So they can know our history, they can build upon that. It might be possible to send multiple messages with updated timestamps and information, Jin added, so that a theoretical alien civilization could learn more about Earth over time. Now, the search for extraterrestrial intelligence, or SETI, can be roughly split into two methods: passive and active. In passive, SETI scientists use massive telescopes to listen or look for hints that intelligent life is out there. Such hints might include radio waves sent either inadvertently or deliberately by an alien civilization. Active SETI involves sending signals. These efforts are far less common, and most, so far, have been largely symbolic. In 1972 and 1973, the Pioneer spacecraft were launched with a pair of plaques depicting a line drawing of a man and a woman, and symbols meant to show where the craft originated. The plaques were the first message from humanity designed to travel outside the solar system, but the chances of them being found in this vastness of space are minuscule. In 1977, NASA launched a similar long-shot effort on the Voyager spacecraft, the Golden Record. The record contains music, animal sounds, and spoken greetings in 55 languages. It was designed by a committee headed by famous astronomer Carl Sagan and was inspirational to the current team of researchers, said Kristen Fay, a science systems engineer at JPL and a co-designer of the new message. To follow up on that has really been just an honor, Fay told Live Science. The new message included a line drawing of a man and a woman similar to those on the Pioneer plaques, but with a more egalitarian spin. While only the man in the 1970s versions was raising his hand in greeting, both the man and the woman are waving hello in the modern illustration, according to Hector Socas Navarro, an IAC researcher. We have no idea whether intelligence is something very common in the universe, or, on the contrary, whether it is extremely rare. For that reason, we cannot know whether these searches have any chance of success. There is no choice but to search and see what we find because the implications would be tremendous. So, scientists are very hopeful for the success of this new message, as they are confident enough to believe that this time they have all the right resources and the right people to do the job. If they are successful, it will completely change our perspective about space and species breathing in it. And this is it for today. What are your thoughts on today's video? Share your views with us in the comments below. Also, don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.